math. There's been a constant debate on whether math was invented or discovered, but whether it was invented or discovered, it shouldn't matter. The fact is, people thought about math. They kept thinking for centuries. And for centuries, math has been evolving ever since because of their efforts. Consider the Egyptians. Their oldest mathematical text is about 2000 or 1800 BCE. The Egyptians' numbering system was based on grouping by tens, and the Egyptians had two numbering systems. And they all placed it in either hieroglyphs or in documents, but their highest number went up to 1,000,000. The Babylonians. Babylon lost a lot of their records, but one records that were discovered were their clay tablets and was devoted to geometry. Their numeral system was based on 60. India. From the early Vedic period, India evoked power of tens from a hundred all the way up to a trillion. They also provided the use of arithmetic operations as adding, subtracting, multiplication, subtraction, squares, cubes, and roots. Records also show that India used the number zero as an actual number instead of an empty space. But no country was more devoted to advancing mathematics than the Greeks. The Greeks' advancement in mathematics was the beginning of what we know math today. Their logic, theory, arithmetic, algebra, and geometry was uncanny to anyone else's, especially their geometry. Their geometry was a dominated form of math in Greek culture. Consider one of the greatest Greek mathematician, Perez, who is known to be the idea behind the Pythagorean theory. You understand what I'm trying to say. It's in his name. Through him, a lot of other mathematicians expanded from his idea and having it proven. And no one mathematician decided to collect all that information and put it in one book. This mathematician was Euclid. And his book, The Elements, also known as Euclid's Elements, is one of the most influential books containing collections of definitions, postulates, propositions, proofs of the propositions, and geometry. The work inside this book was from other mathematicians, but the content was organized all by Euclid. It was he who helped organize everything into one book and also added a few of his original work into it. This book was basically the blueprints to mathematics, geometry especially. Sadly, war and chaos would ruin a lot of this knowledge that these great mathematicians, philosophers, educators worked so hard to produce, only to have it destroyed. Civilizations and empires would fall, and their knowledge would fall with them, including Euclid's Elements. However, there was one country in the Middle Eastern Europe that was on a rise. That country was Islam. Islam, surprisingly enough, helped save and preserve a lot of lost that could have been lost knowledge forever. They would send people to Constantinople to retrieve a lot of text and bring it back to their country to translate. One such place they took all that knowledge to was the House of Wisdom in Baghdad. This house of wisdom was considered a grand library. It existed as a part of the major translation movement, translating works from Greek, Persian, and India sources to Arabic. This translation movement lent monumental to a great deal of original research occurring in the Islamic world for Islamic mathematicians. And of course, one text that they preserved and translated was Euclid's Elements. And from Euclid's Elements and many other mathematicians' work, the Islamic mathematicians would take their information and make it their own. This period flourished and gave power to Islam. This period was called the Islamic Golden Age. And during this age, many strives to mathematics was achieved. So many mathematicians of all different cultures would come together as one, whether you were Jewish, Christian, or Muslim, it really didn't matter as long as you all came together to learn. And one mathematician that helped strengthen and flourish this golden age was Omar Khayyam. He was born in 1048 till 1131. He was a Persian mathematician, astronomer, philosopher, and poet. Working off from Greek texts, he took the concept of irrational numbers and proved that irrational numbers can be on the same numbering system. Euclid was never able to prove that, but Khayyam could tell that pi was greater than 0, and thus he knew that all irrational numbers had a place on the number line. But that was not his most notable achievement. His most notable mathematical achievement was the classification and solution of cubic equations, where he provided geometric solutions by intersections of other curves. I can understand that seems a bit confusing, but what he basically is doing is that he's taking a cubic equation and using geometry and other curves to find one x value of that cubic equation. Let me show you an example.
Alright, let me quickly go over the steps that Khayyam used to solve this cubic equation. His first step is to establish a point of origin. Let's consider this point of origin B. Next, create a circle around the point of origin with a radius of square root C. Next, you draw a second circle around the point of origin with a radius of D over C. Next, you draw a third circle from the D over C radius length here. Next, consider the equation x squared over the square root of C. With this equation, we'll have a parabola, and through this parabola, we'll have an intersection with the third circle here. We'll call this point S. From the intersected point, create a perpendicular line. Go. Let's consider this point M. Now we have a line segment of M and B. This line segment is our first x value. So how Khayyam had it is that the absolute value of MB will be our first x value. And that's how you solve it. Consider this example. I did on this note. I used this equation here, this cubic equation, and you can see through my work that my first circle here has a radius of 4, my second circle has a radius of 8, my third circle has a radius of 4, my parabola is x squared over 4, and with my s intersection, by creating my, and with thus creating my perpendicular line, I get, and you can clearly see that the end point clearly hits negative 4. So the absolute value of negative 4 is 4, giving my first x value 4. So it works.
Khayyam was a genius. He was a major influence in the Golden Age, but he wasn't the only one. Meet Al-Khawarizmi. Al-Khawarizmi was born from about 790 to 850. He was a Persian who produced works in mathematics, astronomy, and geography. He was even appointed as the astronomer and head of the Library of Wisdom, but he is mostly known as the father of algebra, sharing that title with the Greek mathematician Diphanos. He was also a strong advocate of the Hindu numbers, which would later be translated into the Arabic numeral system that we know today, all due to the fact that Al-Khawarizmi adopted it. However, just like Khayyam, Al-Khawarizmi took inspiration from the Greeks, India, Babylonian, Persia, anywhere he could, especially Euclid's elements. He expanded on the geometry of Euclid to write a book of his own, and in this book gives us the very word we call algebra. Al-Khawarizmi developed a formula for systematically solving quadratic and linear equations too, by using the methods of completion and balancing to reduce any equation to one of the 6 standard forms. Note that squares mean x squared and roots mean x. So his 6th standard form was, you have your first one, which is square equals roots. His second one, squares equals to numbers. Third, roots equal to numbers. 4, squares and roots equal to numbers. 5, squares and numbers equal to roots. 6, roots and squares equal to squares. What basically Al-Khawarizmi is saying here is that he can solve any quadratic equation using at least one or two of these standard forms. Let me show you an example of solving a quadratic equation by using one of these standard forms. And we're going to consider the standard form squares and roots equal to numbers. And we're going to consider this standard form, squares and roots equal to numbers, which is also known as completing the square. Alright, using Al-Khawarizmi's completing the square method, we're going to consider this quadratic equation, x squared plus 10x equals 36. Our first step is going to be drawing out a square with x length. Next, we're to draw out 4 rectangles of a length of x and a width of 10 over 4. Why 10 over 4? Well, let's consider this rectangle that has a length of 10 and a width of x. And of course, if we multiply these two together, the area of this rectangle is going to be 10x, as similar to our problem here on our equation. Now, we need to have this added onto our x squared. So in order to do that, we have to divide it into 4 equal rectangles, which will leave us with 10 over 4 as our new width. You can simplify 10 over 4 5 over 2. So now each one of these width is going to be 5 over 2. Now let's clean this up to have a more clear picture. Get rid of that. There we go. Now, let's find the area of this shape. We know if you times x with x, you'll get x squared. And you times 5 over 2 with x, you get 5 over 2x. Does this look familiar? Well, it should be, because this is exactly what the equation is. Thus, we already know what the area is. 39. Now, just as the name of this method is called completing the square, let's complete the square. These empty spaces we know is 5 over 2 by 5 over 2. And to find that area, you times 5 over 2 with 5 over 2, thus giving us an area of 25 over 4 for each one. So let's add our total area of this square. It will be 36 plus 4 and 25, 4. And our total is going to be 64. You see why I did it like this, right? Because there's 25 over 4. There's no reason for me to like add each one, just multiply. Now we know the outside square here has a total area of 64. In order for us to get the length of this outside square, we square the 64, and we know the square root of 64 is 8. So it's going to be a length of 8. But we didn't come here to get the length of the outside square. What we are looking for is one of the x values. And we know, and with our given information, is 8. So if we add x plus 5 over 2 plus 5 over 2 plus 8, we will then get x plus 5 equals 8, resulting in x equal 3. And there you go. Our first x value is going to be 3. And that's how AlChamari solved a quadratic equation using nothing but geometry and a little bit of algebra. Just like I am, AlChamari was a genius, and he helped flourish and strengthen Islamic mathematics. He took a quadratic equation and used nothing but geometry to solve it. And through that, he was able to strengthen and stabilize algebra. The Islamic Golden Age flourished in economics, science, history, literature, and of course, mathematics. They were on top of the world, but sadly, it would not last for long. Just like every other great nation, war targeted the Islamic peoples. Thus, the Golden Age was done. But before it was completely destroyed and all the knowledge with it, there was a man named Adalar Abbas who traveled to Middle Eastern during the Crusaders' War. And during his time there, he discovered a lot of Arabic texts of mathematics. And one of those Arabic texts that he found was Euclid's Elements. He took Euclid's Elements and so much other mathematical works from other Islamic mathematicians, and he brought it all back to Europe, bringing geometry back into what was lost to Europe for almost a century. It was through the Islamic peoples preserving and advancing much of the lost texts from older mathematicians that math today was able to thrive and progress even further. We constantly think of math. By adopting the Hindu numerous system, the Arabic made their own numerous system off it. And from the Arabic numerous system, developed the medieval numerous system, and then to our numbering system today. It just keeps evolving. And we have also the Islamic peoples to thank on proving that irrational numbers can fit on a number line. The Islamic peoples were clever and smart, and these two men, Al-Khawarizmi and Khayyam, were two brilliant men that helped flourish that. It is sad to know that war and blood would destroy so much of so much of their knowledge. But if it weren't for them, algebra would never be systemized. Euclid's elements would be lost forever, and math would be pushed back for who knows how many centuries. Islamic influence in mathematics helped push forward and preserve what was lost. Thank you.